Hello everybody, my name is Joshua Zuber. My student ID is 901011557. I've given you a fancy little thing here, okay? And here's my notes, just so you know I'm not cheating. This stuff, equations of which I'm not capable of memorizing quite yet. I am having ChatGPT quiz me on it, trying to. Some of the stuff I can memorize. Alright. So, first of all, the screenshot. So I have lo-fi playing. I'm going to pause my Spotify. Gallery, there it is. It's water table. Here's my screenshot from the national weather thing. And as you can see, 49 Fahrenheit at 1066.95 millibars. Okay? And I have that stuff wrote right here, along with an empty slot for PH2O and PO2. Alright, so that's that. The first thing we want to do is our pressure, temperature, and volume. We want to convert them, which my marker's up here. Alright. So, gotta erase that stuff. This is about the 15th take of this video. Boom, 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 3 different slots. So, 1066.95 millibars. Well, I know that 1 atmosphere equals 1013.25 millibars. So I'm going to divide this by 1013.25 and I'm going to have the atmospheres on my regular calculator. I have a Casio Scientific and this one here. I only use this for fractions because I kind of prefer decimals. Yeah, 1066.95 right here. 66.95 divided by 1013.25. 1013.25 equals 1.529, but it's really just 1 point, okay, it's a 1.0529. So it's really just 1.05. Okay. 1.05 ATM Fahrenheit. Okay. We're going to go, okay, here it is. So 49 minus 32 equals 17. So back on here, 17, okay, turn it on. 17 times fraction 5/9 equals 85/9. That means nothing to me. So 85 divided by 9 equals 9.44 Celsius. 9.44 Celsius. I'm going to add 273.15 plus 273.15 equals 282.594, so really just 282.59 Kelvin. And we're going to put that up here. So 282.59 with big old K. Why is that up there? Okay, so anyway, 9.44 Celsius and 282.59 Kelvin. And then we're going to take our little towel and erase this stuff because I don't know why I put it up there. There we go. Milliliters, liters, we're going to turn that into that. We'll just divide this by 1,000, so that's going to be 0.0354. I was like 1 point above failing all my high school math. But I've also done a lot of takes on this video, so I know this is correct. And yeah, so we have our calculations measured there. I gotta turn this heater off. It is quite hot. So, turn this back around to my next step. We are going to use Dalton's law of partial pressure, which is P H, it's not capital, okay, I'll make it H2O plus PO2 equals TP. The pressure of H2O plus the pressure of oxygen equals the total pressure. And we can find the pressure of H2O on our water table, which is on my phone. Back one photo. So we are right between 5 and 10 Celsius because we're at 9.44 degrees. 5 and 10 Celsius is our range. So we're going to go 5 to 10 Celsius. And the pressures of that range, if I can't really remember, 6.5 to 9.2. 6.5 to 9.2 torr. Okay? So 6.5 to 9.2 torr. We know that 1 torr is we know that 1 atmosphere is 760 torr. So we go, well, to find the partial pressure, we have this equation. I watched the video, Mrs. Welch, and thank you, because I was having a meltdown because I couldn't figure anything out with that video. I was like on ChatGPT, I was on YouTube, I was on everything. I couldn't figure that out. But I have it turned into a little equation. I don't know if that's really how you write it, but it's how I understand it. So we're going to do that with our thing. Move this over here. So the temperature, which is 9.44, minus the lower temperature, which is 5, minus 5, over high temperature, which is 10 minus 5, why is there a 0? Is equal to pressure minus the lower pressure, which is 6.5 torr. So we're going to actually move that back 1.05 minus, we have to convert now. And also we're going to get rid of this equal sign because it's going to be cross multiplication to figure it out. So there's a little X in there. Okay, so 6.5 torr. We go 6.5 divided by 760 to get the atmospheres. 6.5 divided by 760 equals 0.00855, 0.0086, 0.0086, 0.0086. Maybe we should do that on the scientific calculator so it's a fraction, and we could just put this whole thing into the scientific calculator. Where is it? Aha. Okay. So 6.5 divided by 760. 6.5 divided by 760 equals 13. So there's going to be a fraction inside of our fraction. 13 over 1520. 13 over 1520. Okay, and that's going to be divided, where's my paper? That's going to be divided by our high pressure minus our low pressure, which is going to be another 13 15/20ths. That's a 3. 15/20ths. And our high pressure, 9.2 divided by 760. Oh no, my calculator. 9.2 divided by 760. 23/1900ths. Okay, so we cross multiply to figure this out, because we know that that equals that, which is why that little thing is there. This is the pressure of H2O. Okay, so that's not the 1.5 atmospheres. That's X. That's what we're figuring out. I was like, why do I have all of the figures of this? This is not quite right. So that's actually X. That's what we're figuring for. So we'll go 9.4. Okay, actually, we'll figure out what this thing is. We're going to simplify it first. No, back here. Simplify it first. Okay. Clear. And there's a minus. Forgot the minus. 23/1900ths. Okay, clear. Fraction. 23 1900ths minus fraction 13 15/20ths. Equals 27 over 7,600. 27 over 7,600. We'll grab our regular calculator. 7,600 divided by 27. The button is stuck. There we go. No. It's actually 27 divided by 7,600. So 27 divided by 7,600 equals 0.00325. No. I'm so dyslexia. Sorry. 0.003552. 0.03552. So we can erase this and go 0.00. Actually, we can just do the steps and make another one. So 9.44 minus 5. Okay, actually we did this. 0.0035, and since we're rounding, 36. There we go. Just like that. X minus right there. Okay, 9.44 minus 5. 9.44 minus 5 equals 4.44. So we'll go 4.44. Ten minus 5 is 5. Okay. So that's a little bit simpler. So then we should be able to cross multiply because it's a fraction equals fraction. Now that it's simplified a little bit more, we should be able to go 4.44 times 0.0036. 4.44 times 0.0036 equals 999. Back to the regular calculator for a fraction. I mean for a decimal. But that is 999. I'll just make sure this is right. Anything should be able to be x, right? I believe anything can be x. Let's just read this out. The temperature minus the lower temperature in your range divided by the higher temperature is going to be equal to the pressure minus the lower pressure. Yeah. So 999 divided by 62,500. 0.0159. 0.06. 0.06. 0.06. 0.06. I'll write that over here. 0.06. Okay. So the pressure of our water should be 0.06 atmospheres, and that seems correct. So we're going to go pH2O is 0.06. Okay? So cool. We can erase this equation now because we have found using our water chart, we have found the partial pressure of the water vapor in our tube, and using the Dalton's law of partial pressure, I think I might have said that already, we can figure out how much oxygen we actually have. It's going to be the total pressure minus 0.06. And that's going to be, oh, that's so easy. Okay, come on. Do it. This is going to be 0.099. I have to use my calculator. 1.05 minus 0.06 equals 0.99. I was correct. So PO2 is 0.99. And as you can see here, everything adds up. So that's pretty cool. And we're still recording. Nothing is cut out. So that's even cooler. Can erase that right there from the bottom. And our range, we don't need a range anymore because we've already found our water and oxygen pressure. So now, what we have to do is use the mole ratio in grams and stuff. And I'll explain it better than that. Okay, so on an elemental chart, you know that the atomic mass is literally the same as the molar mass. So like mercury is 200.59 atomic mass, it's 200.59 moles per gram. Oxygen, O2, is 32 moles per gram. If you take one molecule of oxygen, it's going to be 16 moles. Not one molecule. If you take one atom of oxygen, it's going to be 16 moles. But, yeah. Okay. We know how much oxygen we have. Okay? So, let's see what this says. Water pressure on the water table. Okay, yes, the ideal gas law. PV equals nRT. Boom, PV equals nRT. And that can also be written as N equals PV over RT. So N equals pervert. Where is this thing? I found it. And that's the one we're going to be using because we want to find N. Because N always represents moles. So, yeah, N equals PV over RT. And our constant, because we have atmospheres, Kelvin, and liters, our constant is going to be 0.0824. R equals 0.0824. Right there. 821. My apologies. I can't read my own handwriting like I said. 821. Okay. So, N equals PV over RT. So the pressure of our oxygen, all right, I'm just going to erase stuff. Take the P out of there. The pressure of our oxygen, 0.99 atmospheres, 0.99, by the volume, 0.0354, 0.0354, Zero point zero three five four. Zero point zero zero, or yeah, 354. Where is that? 0.00354. Where did I get that number from? Okay, PV. Oh, volume. Okay, liters, volume, liters. Okay, R is our constant. Okay, 0.0821. 0.0821. 0.0821. Times T. Temperature, which is, okay, PV equals nRT. You always use Kelvin, because you always use Kelvin in these ratio equals ratio. So we're going to do the Kelvin temperature, 282.59. Okay. So our moles of oxygen should be equal to that equation, which I've just written out right there. And I'm going to put it into my scientific calculator. Clear everything out. Bracket 0.99 times 0.0354 bracket divided by 0.0821 times 282.59. Equals 0.0015106. And this makes sense because we don't have anywhere near 32 grams of oxygen, so it should be less than 1 mole. So 0.001516. So 0.0015. 0.0015. 0.0015. All right. that should be how much moles of oxygen we have. So that's the oxygen that was produced in our experiment, 0.0015 moles of oxygen. And with that temperature and pressure, that takes up this much space with 0.06 atmospheres of pressure H2O in there. Okay? Now we need to, since we have the moles, we can multiply. That's O2. Because there is one, here's the deal, stoichiometry. There is one oxygen atom in mercury oxide. It's one oxygen, one mercury, okay? And so this amount of oxygen molecules, moles of O2, multiplied by 2, should yield the amount of mercury atoms we have, mercury moles we have. So it should be 0.0030. It should be 0.0030 moles of mercury oxide. 0.0030. We don't really need. Now we're gonna keep the extra. HGO 0.001502. Okay. And because it's one oxygen to one mercury, the amount of mercury produced in moles must be equal to the amount of oxygen produced in moles, because it's one oxygen to one mercury. So, except that's not true. It's going to be, because oxygen is O2, so, yeah, the amount of stuff we reacted was 0.0030 moles of HGO, producing 0.0015 moles of oxygen. And it's going to produce 30 moles of mercury, because only the oxygen gets divided. So 30, not 30 moles, sorry, 0.0030 Hg. Okay? So, yeah, we've converted all of that. We've done all the I believe I've done everything on my script here. Moles make the mass. Oh, no. Moles make the mass. You got to convert to mass. So, that's why I have this thing. Okay. We multiply that by the molar mass. Not multiply. But, okay, mercury, for example, is 200.59 grams per mole. 200.59 grams per mole. So we go 0.0030, 0.0030 times times 200.59. Zero point 0.60. 0.60. Well, 0.601, so it's just 0.6 really. Okay, we know the molar mass of O2 is 32 grams per mole. So 0.0015 times 32 6 divided by 125. 6 turn on. 6 divided by 125. 0.048. And for mercury, wait a minute, that was for mercury, so I've put that 0.6 down on the bottom where it actually goes, 0.6, and then HGO, a little stoichiometry here. The molar mass of oxygen is 32. There's 2 oxygen atoms. Divide 32 by 2 and you get 16. That's the mass that 1 oxygen atom is going to add to a mercury atom. So 200.59 is going to be 216.59. So let's check our little chart. It's not on our chart, but we know it's 216.59, so we're just going to Google it. Molar mass of mercury oxide, 216. There we go. 216.5894. It's 216.59. 216.59. Okay, so I've done my math correct. I did a little bit of stoichiometry to figure that out. Of course, I've done multiple takes of this video, so it's just kind of burned into my brain at this point. It didn't really take much figuring out. But yeah, 216.59 times 0.0030. 216.59 times 0.0030 equals 0.64. 0.64. So, for the sake of proper sig figs, so once again, just to prove this, 200.59 times 0.0030 60. So as you can see here, I've done my sig figs correct. I left out a sig fig the first try, but as you can see right here, we started out with 0.064 grams of HGO, producing, do I have this correct? Am I using grams here? 1 second. Molar mass goes to grams, yeah. So yeah, we started out with 0.64 grams of mercury oxide. It produced 0.048 grams of oxygen, and it also produced 0.060 grams of mercury. So our reactant is this, and heat, and these are our products down here. And for the balanced chemical equation, it's actually really easy. I just kind of forgot about it. But 2O2, that's kind of like the whole thing. So HG O arrow H G plus O2. We actually need 2 Hg because we need 2 oxygen. We'll make 2 Hg. So 2 HGO makes 2 Hg and 1 O2. So that's the balanced chemical equation right there. 2 HGO yields 2 Hg plus 1 O2. I believe I have succeeded. I believe. After this filming stops, I'm going to be checking all my answers to see if I actually got them correct, and if I didn't, it's going to be very disappointing. So, yes, I hope I got everything correct. Have a great rest of your day, everybody. Yeah, I look forward to seeing your feedback on this, seeing what I can do better and what I did well. Stop recording.